so that you can win pride and glory that lasts, at least until you hit the parking lot. So so there's that. How many of y'all are planning on staying today? I just want to make sure I have enough copies. 1, 2, 3, 4, 5, 6. Really staying? You've done this to me before.
Wait, you said after school? Yeah,
Today,
I can,
okay.
but until like 4:45.
Alright, so 6 people for today. I will make enough copies for that. Tomorrow I am for sure going to be here from 12 to 3. For sure.
We can be ready, right?
Say it again?
We can be ready.
Absolutely.
Okay.
If you need to leave early, if you come like that time, I will be here from 12 to 3 for sure. Don't need to check your email. I will be here for sure. I know that. I'm good authority. You have to bring, have to bring your 3-a-day packet with you. Because those are actually the problems you're going to be working through. We're going to do a station rotation. We're going to do all the things. It's going to be a lot of your working, not a lot of my talking, you working. Please make sure you do that. Collect 3-a-day, day 5. I already said the homework assignment is 3-a-day, day 6. All right, multiple choice. Let's look at the ones from yesterday. We're going to stop at 9:02. I'm going to set my little timer because you guys have one final blitz that is going to finish this whole thing off. I only get about 9 minutes. When this goes off, no matter where we are, we stop because I want you to be able to do one more station rotation. Okie dokie. Question number 21. Did not go so well for us. This was not kind. We've got a table of values shown above, differentiable function f and its first derivative. Use a left Riemann sum. Okay, we've done that before. With 3 subintervals of equal width. Done that before. Which of the following is an approximation of the length of the graph? Yeah. Not the area, the length. There is a formula that is really important to us in order to figure this out. Arc length formula. Who's got it for me? How do we find arc length?
The square root.
There's a square root. 1 plus the derivative, or f dy dx, f prime of x, squared dx. And we're integrating from 1 to 7. Now, if you had the derivative, you'd plug this into the calculator and life would be good. But you don't. So what you need to do is you need to say, what would Riemann say to do? I'm supposed to go from 1 to 7 with 3 subintervals of equal width, so each of those has to have a width of 2. And if it's the left, I'm going to use 1 and 3 and 5. Okay? So to do this approximation, you need the square root, like this means I need to take attendance, the square root of 1 plus the derivative squared. What's the value of the derivative on the first interval? If it's the left endpoint method. 2. So it's the square root of 1 plus 2 squared times dx, that's the width of the interval. So we're going to multiply by 2. Is everybody okay? Plus, what about this next interval? We've gone from 1 to 3. Check it off the list. Now I'm going 3 to 5. How do I find a length on 3 to 5?
Oh, it'll be the square root.
Square root.
1 plus.
1 plus.
And then
I'm on the interval 3 to 5. I'm using
So,
the left
1 squared.
endpoint method. 1 squared times that with 2. Plus the last one, you guys are good pattern people. 1 plus derivative squared times the width. And then you would simplify. The key is, this is the way that you would find the exact value of the length. They're asking you to approximate it. And so in your approximation, you're just going to use this expression here, evaluated at the left endpoint, times the width of the interval. And I think if all goes well, you're going to get, is it D? D. For all the friends that didn't get this, are we okay? All right. So that takes care of that one. 22. When the timer goes off again, we're going to stop no matter where we are. 22. You know, I want to skip 22. Unless there's like really strong feels. I think our time is better spent on 24. 24 went very badly. Now, here's the thing, with the blitz, the reason that we're doing this blitz is I really am trying to get your brain synced up for like 2 minutes a question, 2 minutes a question, 2 minutes, I only have 2 minutes, I gotta move fast. It is very likely if you don't stay in this 2 minutes per question, you may not actually even make it to question number 24. Now, I'm not being mean, but like, if you do not keep a good pace, that hour is gonna go by and you're not gonna see question number 24. There are sometimes easy questions at the end of the test. Make sure you see them. Make sure you see them all. All right, which of the following series will converge? Are there any that we know the fate of already?
Number 1.
You know about number 1? What do you know about number 1?
Going to diverge.
Why?
Oscillation, basically.
The sum, right? 1 plus negative 1 is 0. Now I add 1, I'm at 1. Now I add negative 1, I'm at 0. Now I add 1, I'm at 1. The sum is either 0 or 1, which means diverges by oscillation. So, which of the following series converges at 1 only? Absolutely not. Is it 1, 2, and 3? Absolutely not. Any other ones that we know the fate of just by looking? You're frozen for a little bit. Lewis, which one?
2 converge.
Which one?
2.
Will 2 converge? Why do you think 2 is going to converge?
Because it'll approach 0 because the denominator is bigger.
So here's the thing, I agree that the terms are going to get closer and closer to 0, but what we're asking about is the sum of the terms. And if you add up the sum of the terms, it may or may not converge. I would hope number 3 is one that we know the fate of. Andrew, what do you know about number 3?
Geometric.
It's geometric. 1, 1/3, 1 over 3 squared, what do we multiply by?
1/3.
It's geometric. Your common ratio is 1/3, which is less than 1. Converges. So that means 3, oh, I should have done it that way. 3 converges, so it can't be 2 only. Oh, rotten College Board. It's either C or it's D. You're gonna have to figure out this guy over here, and here's what I did. I said, okay, what if I think about it in this form? 1 over
With 2 diverge.
2n minus 1. How could I test that series for convergence or divergence? What are options that we have? I can think of a few options here. Give me something.
If it diverges, you can use the nth number test.
Okay, you could use the nth term test, right? The nth term test. What happens if I take the limit as n approaches infinity?
0.
You get 0. Conclusion? Don't fall for it. There is no conclusion to be made here. Nth term test is only for divergence, not convergence. Other options? It's been a while. How about doing something like a limit comparison test? The limit comparison test is you'd say something like, these are my a sub n's. Is there a series that I know well that I can say, what's the limit as n approaches infinity of the a sub n's over the b sub n's? And what I might choose to compare it to is that series there, which we know the fate of. Right, this is your harmonic series. Harmonic series, what do we know about harmonic?
Diverges.
Diverges, so what happens here? You get the limit as n approaches infinity, 1 over 2n minus 1 divided by 1 over n. Well, that's the same as limit as n approaches infinity of n over 2n minus 1. That limit is a half. The important things here, finite, positive. Is it both of those things?
Yes.
Finite and positive, so whatever this one does, this one does. That's how the limit comparison test works. And so the result here is going to be, this guy diverges, correct answer, C only. All right. There's that. 24, 25, no, oh, 26, shame. Shame on all your houses and my house this morning. 26. For x greater than 0, derivative of the integral of 1 over the square root of x of 1 over 1 plus t squared. If I'm going way too fast, I'm going to get excited because I know how to find the integral of 1 over 1 plus t squared. This is arctan. And then I'm going to evaluate. And I'm going to take a derivative. What a stupid way to spend my time. Stupid. Why is that stupid? Why is that the stupid way to spend the time?
You already have.
Integrating, finding the derivative. There's something else here. Derivative of the integral of a function. Lewis, what do we got here?
This is the function.
It's the what?
Will be 1 over 1 plus t.
No, that's a different kind of stupid. But thanks for playing. Thanks for playing. The derivative of the integral of a function. This is your second fundamental theorem of calculus. The second FTC says when you're in a position where you have the derivative of the integral of a function, what happens? What I heard Lewis say is it's just the original function that would be bad. Because you're not ending at something really basic like a variable. You've got something more complicated as the upper limit. What happens? It's not 1 over 1 plus x squared.
1 over.
It's 1 over...
1 over 1 plus x.
Okay, and I'm going to write it this way. It's 1 over 1 plus whatever your upper limit is, squared. Still not the answer. You need chain rule now. Right? It says then times the derivative of the square root of x, which is 1 over 2 square roots of x. Square root of x, the whole thing squared, as Celeste just said, is 1 plus x. 1 over 2 square roots of x. If I multiply those together, that's going to give me a. Right, Lewis, what I heard you say the first time was, oh, not even one of the options.
No, it wouldn't.
And the one I think a lot of people would pick is this one? Yeah. And the one I picked this morning, because it was like a whole different level of stupid happening in the house, I went with this one.
Whoa.
But, you know, that's what happens when you do math at ridiculous o'clock. Alright, I know the timer went off, and for some reason I'm ignoring that because there's one more. 77. 77. The number of antibodies Y in a patient's bloodstream at time t is increasing according to a logistic differential equation. Logistic growth, it's been a while. It's been a long while, but there is a formula, and if you didn't remember it, you want to write this one down. Basically, this is the one that said something like dp dt is a constant times your population times the difference between your limiting capacity or your carrying capacity and the current population. So if we have logistic growth, which one?
E.
Has to be E. Right? It's the rate that your population is changing is jointly proportional to your current population and the difference between your limiting capacity and your current population. And so that's just one, like, you gotta know it. Don't spend a lot of time there. Okay, everybody good? All right, you've got the next 10 minutes to visit any one of the stations that are out here. What I would say, though, is don't go to a station that you've already gone to. You're only gonna have 10 minutes, so pick a station that you're like, hey, I haven't gone to, what's over here? Tricky A-B questions. Series, we've got some people that haven't made it over here. I guess everyone's going to differential equations. We've got advanced integration techniques and vector valued parametric polar curves. Make it happen. All right, one more tile. Gotcha. We'll make this work. Okay.
Mr. D,
Yep.
do you have more copies for series?
I don't have more copies for series, which must mean that everyone's gone to series. Or somebody went to series twice. And let's see. Am I prepared for even this emergency? Hey, look at that. You can keep it.
Alright, thank you.
If you want me to sign it, it'll be worth more.
What was that?
There's nothing in here.
For all the friends in the room, when the timer goes off, that's going to be the signal to switch into your final blitz mode. And you're just going to go to the end period. So for the friends watching at home, not sure why, but I'm not able to project my laptop right now. So I'm going to work through, this is in the station's rotation. It's the one for vector valued parametric and polar curves. It's question number 11. It is absolutely calculator active. Absolutely calculator active. I just won't be able to show my stuff right now. Alright, so 11, the polar curve r is given by r equals 3 theta plus sine theta, where 0 is less than or equal to theta, less than or equal to 2 pi. Absolute first thing I'm going to do is I'm going to sketch this on my calculator. When I did that earlier, what I saw from my graph looked something like that. It actually does go all the way around, but on my calculator, unless I adjust my window, I only get to see about this part. So this is r, 3 theta plus sine theta. In part A, find the area in the second quadrant enclosed by the coordinate axes and the graph of r. So I need area in polar, that's always 1/2 the integral of r squared d theta, from starting point to ending point. Because I'm in the second quadrant, I want to be over here, which is between these two angles. Think about that windshield wiper. I need to go second quadrant. So this guy over here is pi over 2. This guy over here is theta is equal to pi. To find that area, 1/2 the integral from pi over 2 to pi r squared d theta. Seriously, all you need to do, type this into your calculator, and you're going to get 47.513. This is worth 3 points. They gave 1 point for the integrand, 1 point for the limits and the constant, 1 point for the numerical answer. You just need to know that formula, and you need to know how to work with it. For all the friends in the room, is everybody okay? Alright, so you guys have 26 minutes to do roughly 15 questions. That's not really 2 minutes per question, that's less than you would actually get. But I just want to give you guys this last final push across the finish line so that I have the data from all 45 questions. David, if you can stop by during lunch and finish off, do the ones that you missed yesterday, that would be great. Lewis, you are going to stop by today to do that. And I can score them this weekend, get you guys the data on Monday. That is going to really be helpful to figure out that last push. Enjoy the ride. This whole thing is calculator active. The only answers that matter are the ones that you put on the answer document. Alright, I'm going to keep going. This is B. For pi over 2 less than or equal to theta, less than or equal to pi. There is 1 point P on the polar curve with x coordinate -3. Okay, you say so. Find the angle theta that corresponds to point P. Well, let's get our hands on this. I want to find the y coordinate of P. What's so special on this polar curve? The x value, if I think rectangular, the x value is somewhere over here at -3. And so here's the point P. Yeah. Brought calculator yet? Alright. For pi over 2 less than or equal to theta, less than or equal to pi, I'm up here. Because technically, there is another point down here where the x value is -3, but that's not the point I'm interested in. I'm told specifically to look in the second quadrant. Alright, there's 1 point P with the x coordinate of -3. Find the angle theta that corresponds to point P. In polar, we always think about radius and angle. I need this angle that gets me to that point. One of the important relationships in polar, or that connects polar to rectangular, you've got that the x value is r times cosine of theta, y is r times sine of theta. We know that x is -3, so that means that -3 is my radius, in this case 3 theta plus sine theta, times cosine of theta. God bless. Now, here's the problem with polar. You can't actually do any of the analysis that you normally would do with rectangular. you're not able to say, like, let me let x equal -3 and find an intersection point. God bless you. God bless you all, especially next Tuesday. Right. You can't just do that. Instead, what you have to do is solve this equation on your calculator. What you could do is switch over to rectangular mode, call -3 your initial function f1, call all this mess your second function f2, because in that case you'd be graphing in rectangular. You'd graph 3x plus sine of x times cosine of x. You'd look to see where they're equal, which means it's an intersection point, and what you're going to get is that theta is approximately 2.0169, or 2.017 is going to be fine. That's not the answer, it's part of the answer, because they said there's one point P with x coordinate -3, find the angle theta. We found theta. Now find the y coordinate. To get the y coordinate, we need y for 3 theta plus sine theta, because it's the y, times sine theta, and then we evaluate this expression at theta is 2.0169, and if all goes well, your numerical answer is 6.272. They awarded 1 point for setting this initial equation up, a second point for solving the equation, the third point comes in for coming up with the numerical value. All right, last part, part C. A particle is traveling along the polar curve r so that its position at time r is x of t comma y of t, such that d theta dt equals 2, find dy dt at the instant theta equals 2 pi over 3. Interpret the meaning. Okie dokie. So what they tell me is d theta dt is 2. We want dy dt at theta is 2 pi over 3. Well, let's take stock of what I know here. Dy dt means find the derivative. Specifically, find the derivative of y, which we know is r sine theta. 3 theta plus sine theta times sine theta. That's the y value. I need the derivative, but we've got to be careful. I'm going to take the derivative of y with respect to t, not the derivative of y with respect to theta. Well, how does this work? Let's see. dy dt, I've got a product here. I'm going to take the derivative here, which is 3, derivative of theta, d theta dt, plus derivative of sine theta is cosine theta, times d theta dt. What I just did is I took the derivative of everything in the parentheses, but I'm doing it with respect to t, times sine theta. Product rule says derivative of the first, times we leave the second alone, plus the first, times the derivative of the second, that's cosine of theta, d theta dt. That's the derivative, first point. They want dy dt when theta is equal to 2 pi over 3. dy dt at 2 pi over 3 is going to be 3 times d theta dt. Well, what's d theta dt? They told me 2 plus the sine of 2 pi over 3, and it's the free response part of the exam. I'm not going to simplify. Whoa, not cosine. Not sine, sorry, cosine. Times d theta dt, still 2, multiplied by the sine of 2 pi over 3, plus 3 times 2 pi over 3, plus the sine of 2 pi over 3, times cosine of 2 pi over 3, times 2. And as tempted as you might be to simplify, there's no need to simplify. Don't worry about doing that unless for some reason you just absolutely have to. If you do decide to do this, what you're going to get is dy dt at theta is 2 pi over 3 is approximately negative 2.819. All of this up here before you simplify is also negative 2.819. So they're equal, and you're going to get the point regardless. The interpretation, dy dt at theta equals 2 pi over 3 is negative. So I would say something like this. At theta equals 2 pi over 3, the y coordinate, what's it doing? The y coordinate is decreasing at a rate of 2.819. No units are given, so don't make up units here. Now, you might be tempted to say, well, if the y coordinate is decreasing, if the y coordinate is getting smaller, the mistake would be to say that if the y coordinate is getting smaller, that you're getting closer to the x-axis. And here's why it's a mistake. What if your point is down here in the third quadrant, and the y coordinate is getting smaller? That means it's getting more negative. You're actually moving away from the y-axis in this case. So I would just say y coordinate is decreasing, and get out of there. And that's it. That's the final point. Friends in the room, we're okay? Okay. You guys get 16 more minutes, plenty of time. Very likely I'm going to be filming this next question. It's a little bit of a long one. When you're done, just leave the multiple choice answers in the middle of the table. I'll pick those up. I'll score them. All will be well. I've already picked up the homework. And I'll see most of you at the end of the day. And is pretty much everybody coming tomorrow? You can't.
I'll just leave early.
You what?
I'll be leaving early.
And you're going to leave early and you're going to do this early. I think you should be